Hello, mathematicians. In this video, you're going to learn about a third way to write a linear function, standard form. Now, you already know about slope-intercept form, y equals mx plus b. This is fabulous when you're really thinking about the function form of your linear function. You input x, multiply it by your constant rate of change, add this, and out comes y. The other form we know about is point-slope form. Y minus y1 is equal to the slope times x minus x1. This version is so useful when you're trying to write the equation given 2 points or a table of values or maybe a graph. Today we're going to now look at standard form. You've already had a little bit of a preview for standard form when we did the flea market problem. The general form for standard form is capital AX plus capital BY is equal to capital C. Here, our X and Y, as always, is representing any point on the line, any combination of X, Y that makes the equation true, just like it did in point-slope form, the X and Y, and slope-intercept form, the X and Y. They all mean the same thing. Now, A, B, and C are going to be numbers. And we'll look at an example in just a minute. As a little side note, I want to tell you that there are several restrictions to A, B, and C. And some mathematicians are very loose about these restrictions. Other mathematicians are very strict about them. So if you're curious to know more about the restrictions to A, B, and C, I encourage you to watch the Digging Deeper video that's going to be later on in this playlist. Next, let's kind of look at a couple of examples for standard form. We have 4.5x plus 6y is equal to 108. This was the equation we used to model our shopping at the flea market. Here's another just general version. X minus 3y is equal to 15. In this example, our A value is 1, our B value is -3, and our C value is 15. Now, a couple of things about standard form. It's really useful when our two quantities, X and Y, are really two independent variables, like in our flea market problem, like t-shirts or shorts. So there's no clear input variable that's independent and then a dependent variable. So useful when they're two independent variables. That's the time when we'll often use it. Another thing about standard form is if you have standard form, it's super easy, not just easy, super easy to find the X and Y intercepts. And let's look at an example of how to do that. Let's continue with the same example equation. X minus 3y is equal to 15. And let's start by finding the x-intercept. I always just abbreviate that int for intercept. And the x-intercept is what is the value for x, the x-intercept, what is the value for x when y is 0? So for the x-intercept, y is equal to 0. So we can take our equation, substitute y for 0, 0 for y, and notice this term, anything multiplied by 0 turns into 0, and we're left with x is equal to 15. So our x-intercept is 15, 0. X is 15 when y is 0. Y-intercept, what is the y value? Y-intercept, what is the y value when x is 0? So when x is 0, can substitute that in. And 0 becomes 0, and we're left with -3y. Watch that sign. Divide both sides by -3, and y is equal to -5. So our y-intercept, when x is 0, y is going to be -5. So super easy because you notice when you set y to 0, you're left with that term, the x term, and when x is 0, you're left with the y term. Next, let's say we wanted to calculate the slope. Our change in y of our change in x. We need 2 points to be able to calculate change, so why not use our intercepts? Those were such easy points to find, so I can use those for my slope. I have 0 minus a -5, and then my change in x is 15 minus 0. Notice I'm keeping my order. 0 and 15 came from this point. -5 and 0 came from this point. And do my arithmetic, and I'll get 5 over 15, or a slope of 1/3. So super easy like that. Finally, let's end with a little bit of graphing. If I need to graph an equation written in standard form, the easiest way to graph this, or the first thing to try, is get the intercepts. Can you use the intercepts? So I'm going to make a little table for my x and y. My y-intercept, x is 0. My x-intercept, y is 0. And let's go ahead and find these. When x is 0, I'm going to get 2 times 0 plus 3y is equal to 12. 3y is equal to 12, and y is equal to 4. All right, and then when y is equal to 0, I know that this term is going to turn into 0, and I'll simply be left with 2x is equal to 12, and x is equal to 6. And now that I have 2 points, I'm going to plot that. 0, 4, the y-intercept, 6, 0, the x-intercept, and then I would take a ruler, a straight edge, and connect those points and extend it throughout the coordinate plane to graph my line. All right, this video, I hope you have a good now introduction to standard form. It's a great form to use when neither your x or your y is the independent variable, when they kind of can either be the independent variable. It's also really easy to find your x and y intercepts using this form, and it's a great way to graph lines written in standard form, find those intercepts, and then graph them. All right, time for a little practice. See you soon, mathematicians.